us using Python to access databases. And we're going to start with relational databases. And because this is not an introduction to relational database design, I would appreciate it if you would stop the video now and read through several tutorials about what relational database design is getting at. And so I have here links to two short tutorials. One is from a Chinese university, another is from Oracle. So read through these, get an idea of what we mean by tables and the different designs we can have, and why we're splitting data up between multiple tables instead of just one big table like you would typically have, say, in a Excel spreadsheet. Okay, welcome back after doing your tutorial reviews. So there's generally now we would label databases in two types: relational, which would be a SQL database, and then what is commonly now referred to as NoSQL. Relational databases are on the latter end of database design. So the first publication related to relational databases was in 1969 in an ACM publication. And prior to that, we had graph databases and hierarchical databases. Those of you in the clinical informatics world, MUMPS, which is what the VA medical record is based on, is a hierarchical database that goes back to the 60s. But with the design, with the publication of the relational database model, within about 15 or so years, the first SQL standard was published, and now relational databases like Oracle, MySQL, Postgres are the dominant databases in use today. Now, NoSQL has kind of made a comeback related to large data sets, and it basically has to do with the cost of doing SQL joins and the cost in terms of the spinning disk hardware seek time. And so different database designs that don't rely on splitting data up across different tables have become popular for particular applications. So like MongoDB, which I'm trying to work out some materials for you. Cassandra is a NoSQL database, I believe, developed by Facebook. Zope database is really an object-oriented database, and this is really what got Python famous in the late 1990s. And of course, many more. If you search on, just do a search on databases, you'll find a wide variety. So this is an excerpt from a Wikipedia article about the relational model. Again, I would suggest going through and just reading through it or scanning over it. The reason that relational databases became so popular is because it's based on first-order logic, and so it's possible to precisely define a query language. And so it's really this ability to specify queries in a logical mathematical format that these databases became so popular. So let's just review some basic SQL concepts, and then we'll move into examples using a specific relational database. So all the data is going into tables, and so tables are like the building blocks of this relational model. And so this quote from the Definitive Guide to SQLite: before you can do anything, you have to understand tables. And so tables consist of rows and columns. And so columns are variables. They have names, they have types, and the rows are specific instances of an observation. So at this stage, a table I imagine most of you have worked with tabular data in like an Excel spreadsheet or a Google spreadsheet. So it's the same idea. We have these columns of different data types, and we have rows with particular observations of those data types. So we create tables, and when we create table, we specify what those columns are, what those data types are, etc. And then other things that we're going to do is we're going to modify those tables. And we're going to modify them by inserting values into the table, deleting values, altering values in the table. And then once we've put data into the database, we of course need to be able to, for it to have any value, pull data out, and we do that with select. And so, as this quote says, the select command is the most complex command in SQL, and it becomes complex because we can ask various questions of what we want to select, what we want to return. And the select command has a where clause, and then the where clause becomes the most complex aspect of the select clause. Okay. So Python defines a relational database API. And the purpose of this API is to ensure that people developing specific modules or libraries or packages for a particular database like MySQL or Postgres or SQLite or Oracle, that the functionality will be very similar regardless of what the underlying database that you're using is. And so there are there are three important global variables that the API defines to exist in any Python database application. So the first is the API level, and so there's values 1, 2, or nothing, which means the absence of a value means it's not 2.0 compliant. And then you have this idea of thread safety, and the thread safety relates to how this database can be used in concurrent programs. Concurrent programs are programs that have different processes running in parallel. And then the param style, which I have a typo here, tells us how values are spliced into SQL queries. Or this is like analogous to the string interpolation we do, where we define a string and then we insert integer values or string values into it. And so there's different ways that the APIs will do that. And one is the value format means we're going to use C-style formatting, which is more or less what we've been doing when we've been doing the string interpolation. PyFormat is a Python extension of the C formatting. Numeric, named are ones that I haven't worked with because none of the databases that I've worked with have those. And QMark simply means we're going to put a question mark in our string, and then that will be replaced by some value that's being inserted into the SQL statement. So what do these look like in different packages? So SQLite, which we'll talk about in the next notebook, is a very simple relational database, and it module for interacting with SQLite is integrated into Python. So we can import SQLite 3, and I don't know why, I just hate having that 3 on there, so I always import it as SQLite. And we see that the API level is 2, the thread safety is 1, so threads may share the module but not connections, and the param style is QMark, which means when I create a SQL query or a SQL statement, that I use a question mark. And so this is an example of what I mean. So in this case, I'm creating a SQL statement to insert into the table the following values. And there's 1, 2, 3, 4, 5 values that are going to be inserted in. And this purchases would be a 5 tuple where the first element of purchases would be inserted into this value and so on. Now, it's an important point that we never explicitly create the string the full SQL statement using Python string interpolation. We always let the cursor or the database API do that insertion for us because it has methods of protecting against harmful statements being inserted into the SQL statement. Like so we never, just in summary, we always let the API do the interpolation for us. All right, so there are other databases out there. So let's just install some packages. We don't have to have the database. We don't have to have access to the databases to see how they'll look. So there's several MySQL packages we can use. So the first one, these come with Anaconda. So we can use conda install PyMySQL. So PyMySQL is a pure Python MySQL package. And if we install it and then we import it, we can see that it, on the one hand, looks fairly similar to the SQLite. It has API level 2, it has a thread safety of 1, but in this case it's using format, which means we use C-style formatting for creating our SQL statements. And so here you see we have a cursor, we're doing the execute statement, and we're inserting into a table TZ data, and I just pulled these out of the documentation for each of these packages. We're going to insert into the values, and here we have the string markers %s, and these 3 values are going to be inserted into the SQL statement that then will be executed. Okay, MySQL comes with official Python bindings, and that package is called MySQL Connector Python. Again, we can install this with conda. We import mysql.connector, and again, it looks fairly similar. It's API level 2, its thread safety is 1, but in this case, it's using the Python extended formatting for the parameter styles, and in its simplest forms, it looks just like the C-style formatting. So we're going to insert into the table employees, into the columns first name and higher data, the values that are then spliced in with this %s symbols. I think I lost something in my copy. Well, I have the statement, and then I'm doing this execute the statement, and data would be a 2-tuple, a series of 2 tuples that are getting in. So we'll look at execute many in a later notebook. Postgres is another open source relational database. So the package for interacting with it with Python is, how would you pronounce this? Scicop G2? I don't know. We can install it with conda. We can import it. And so see here now we have a thread safety 2. So this is a database API that facilitates more concurrent usage. So threads may share modules and connections, but not cursors. Honestly, I don't know what that means in practice. And the param styles are the same as used with the MySQL connector. And so here we create a cursor. We have a cursor. We're going to execute. We're going to insert into a table named test, into the columns num and the column data. The 2 values which are going to be replaced here with the string substitute, with the interpolation, the value 100 into num, and abc def into the value data.